Okay, guys, so we learned what proteins are and how they are shaped in their specific structure. So now we're going to learn about the most common, at least the most common talked about use of proteins, which is as enzymes. So what enzymes are biological catalysts. Biological, specifically protein. So when I say that, though, your understanding what I mean by that is dependent on if you understand what a catalyst is. So let's go back to look at the definition of a catalyst. So a catalyst lowers the activation of a reaction to speed it up. So it does speed it up, but it doesn't just make things go faster, right? It lowers the amount of energy needed to get the reaction to occur. So if we look at this reaction coordinate diagram on the right, our starting materials are over here on the left, and then our products are over here on the right. So the greenish blue line is the activation energy without the enzyme. So it requires, I don't know what units these are, it requires this amount of energy input in order to get the reaction to occur. So this is the energy of activation. However, if you have a catalyst, it will somehow, through some interaction, maybe hydrogen bonding, covalent bonding, something like that, it will make it so that the reaction requires less energy to go. So that would be like this purple line here. So you can see it's half the amount, even just with this cartoon, it's less. It's easier to get over that hump. Think about how much energy it takes to run up a hill. If it's a really tall hill, it's going to take more energy. If it's a shorter hill, it'll be less. So our catalyst is going to make the hill shorter for us. So looking at an example is carbonic anhydrase, so CO2 and water equilibrate in order to form this HCO3- and H+. So just for example, the non-enzymatic, so non-catalyzed reaction, there are 0.13 reactions per second just naturally. However, when you have an enzymatic reaction, so this enzyme, carbonic anhydrase, helps to speed up this reaction, you get 1 × 10 to the 6th reactions per second. So it's almost 1 million reactions a second. Actually, it is 1 million reactions a second for a 7.7 × 10 to the 6th. So 7.7 million fold enhancement in rate. So it makes it go 7.7 million times faster. And then why did evolution make it so that we had these enzymes? Why does nature use enzymes? Well, in our bodies, we have, at least humans, we have 37 degrees for our body temperature around our bodies. And then we also have a pretty neutral pH of 7.4. So overall, our bodies have very mild conditions. The traditional ways you get chemical reactions to go faster are by changing the pH or heating it up, adding more reagent. We can't do that in our bodies. Our nature can't do that. Can't just have like, oh, we're going to heat up this part of your finger right now because it needs this reaction to occur. No, it doesn't do that. So we have to have mild conditions, and we need the reactions to occur quickly so that we can regulate the functions in our bodies. So enzymes are really important to make sure that we can get fast reactions, everything's regulated at a very mild condition. So I'm going to put a big square around this. Key points to remember about enzymes. Just like overall big picture about enzymes and what they do. The first one is that they are catalysts, so they lower activation energies, faster rate of reaction. The second one is they are functioning at mild conditions, so they have a lot of interactions that allow these reactions that typically would be higher in energy to occur at a lower energy. It stabilizes things. Number 3, there's greater specificity. So you'll see later about specificity. Specificity just means it's a specific reaction. So you're going to react a very specific part of a molecule in a very specific way, specific reaction. So there's way more reactions that enzymes can do than just what we've talked about so far in terms of types of chemical reactions. There's way, way, way more. So these enzyme catalysts allow for very specific reactions to occur. And then lastly, regulation. So enzymes are responsible for regulating. So if there's a lot of starting material, so if we look back at carbonic anhydrase, if there's a lot of carbon dioxide around, carbonic anhydrase can deal with that by making more of this HCO3. But if there's not a lot around, it can slow down. So it can kind of change its rate dependent on the concentration of different things. So it helps regulate different molecules in our body.